Okay, so we're going to talk about continuity with respect to functions, and there's a specific definition that you have to follow, just like when you're evaluating the limit, you have to use the definition of limit. So for continuity, we're saying that a function f is said to be continuous at x equals c at a given point, provided the following conditions are satisfied. So this involves the limit. So what they're saying here is that the limit as x approaches c of f of x must exist. So basically what you're looking at is that the limit as x approaches c from the left of f of x is equal to the limit as x approaches c from the right of f of x. They have to be equal to each other, which is really how we evaluate the limit anyway. Okay? Then we also need to look to see that f of c exists and that c is in the domain of f. Okay, so what this means is that you have a point c comma f of c. So that also has to exist. So the limit has to exist and the point at that given value c has to exist. And if they do, okay, then you're looking at the limit as x approaches c of f of x must be equal to f of c. So these two could be true, but if they're not equal to each other, then the function is not continuous. So what you're looking at, for example, is the function from -2 to 3 continuous? And if we just pick something random on here, so let's say we're looking at the limit as x approaches 1. The limit as x approaches 1 from the left is 1, from the right is 1, and f of 1 is 1. So all of those are equal to each other. So in this example right here, we have this piecewise function, this crazy function here, and it's graphed here as well. So what we want to know, these are just yes or no questions, does f of -1 exist? F of -1, yes. The point exists. You're just looking right here at f of -1. Does the limit as x approaches -1 from the right exist? -1 from the right. Yes, it exists from the right. Okay. Does the limit as x approaches -1 from the right and f of -1 equal each other? Yes. Is f of x continuous at x is equal to -1? Now, the other side that we didn't look at here is the limit as x approaches -1 from the left. It's this piece right here. Do we have any portion of the graph that approaches from the left? No, we do not. So we cannot conclude that the function is continuous there. We don't know what's happening from the left. On the other side, let's look at discontinuity. If a function has a discontinuity at some given point x equals c, then there are two types of discontinuities. Two types. Okay, the first type that we're going to look at is a removable discontinuity. A removable discontinuity. Shorthand RD. So you can use this to designate a removable discontinuity. And what this means is that there is a hole at x equals c. So what you're looking at is the limit of this function as x approaches c from the right and from the left are equal to each other, but they're not equal to that given point. And here's an example. If you're looking, the limit from the right and the limit from the left are equal, but this is the point. Here is the hole. So this is known as a removable discontinuity. The other type of discontinuity is a non-removable discontinuity. Okay, and shorthand is ND. So you can use this. But a non-removable discontinuity has two junctions, meaning you need to identify, is it this type or this type? This first type that we're going to discuss is a jump discontinuity. Okay, and it is exactly what it sounds like. There's a jump in the graph. So the limit as x approaches some given value c from the right of the same function is not equal to the limit as x approaches c from the left of that given function. Here, whatever this number is, if I have the limit as x approaches c from the right, I'm up here, let's say at +4, and then the limit, or this is from the left, excuse me, Then the limit as x approaches c from the right is down here at 2. They do not match up. So in this case, the limit does not exist, and you would state that you have a jump discontinuity at x equals whatever that number is for x. The other type of non-removable discontinuity is known as an infinite discontinuity, ID, and this is a vertical asymptote. Okay, and when you have a vertical asymptote, what happens is you are approaching different values, meaning when I approach, what is this, -2, from the right, my graph is going to positive infinity, and from the left, negative infinity, therefore this limit does not exist.